In section 10.2 and 10.3, we're going to look at special right triangles. The first special right triangle we're going to look at is called a 45, 45, 90, and the second special right triangle in section 10.3 that we'll look at is a 30, 60, 90. So what is a 45, 45, 90? Any isosceles right triangle will always contain one interior right angle and two interior angles that measure 45 degrees. So if you have an isosceles triangle, we know that these two angles have to be the same, and if you have a right angle, these both have to be 45 degrees. I'm going to skip through this exploration, but I'm just going to show you that if we were to use the Pythagorean theorem to find the length of the hypotenuse, C, our hypotenuse, is going to equal 2 square root of 2. Here, C is going to equal 3 square root of 2, and here, C is going to equal 4 square root of 2. So you might notice a pattern. This leg length here, so that they're all square root of 2, and then you'll notice this 3 is here, and you'll notice this 4 is here. Okay, so that is a pattern. So that is what a 45, 45, 90 triangle is. The length of the hypotenuse is the length of the leg times the square root of 2. So if you guys saw here, the length of the leg is 2, so the length of the hypotenuse is 2 square root of 2. You take the length of the leg, multiply it by square root of 2, and that gives you your hypotenuse. You take the length of the leg, multiply it by square root of 2, and that gives you the length of the hypotenuse. So I'm going to call, so each leg I'm going to call L and L, and then the hypotenuse is going to be the length of the leg times the square root of 2. So you can see that indicated here. Our hypotenuse across from the 90-degree angle is the length of the leg times the square root of 2. So what I'm going to have you guys do for these types of problems for special right triangles is you're going to set up a ratio. So we're always going to do 1, 1, and square root of 2. So 1 and 1, these are going to be your leg lengths. So in this case, 3 and 3. Okay, and then under the square root of 2, you're always going to put the length of the hypotenuse. So our hypotenuse is across from the 90-degree angle, which is x. Now, the only unknown here is x, so we want to try to solve for x. And the way that we're going to do that is we're going to, so these are all equal ratios, we're going to cross multiply. Okay, since both of these are 1/3, they're always going to be the same because the leg is the same. The legs are the same because it's an isosceles triangle. So it doesn't matter which one you use. So now we're going to cross multiply to find x. So 1 times x is just x, and 3 times the square root of 2, well, 3 is not under the radical, so he can go on the outside, and then times the square root of 2. So that's our hypotenuse, which we know because the hypotenuse is our leg length, which is 3, multiplied by the square root of 2. So if you don't want to set up this whole thing for this type of problem, you can just recognize that it is the leg length times the square root of 2 and be done. Same thing here. Since these are both 45-degree angles, we know that if this leg is 4, then we know this leg is also 4. And we know that the hypotenuse is the leg length times the square root of 2. Okay. And then I'll just show you if you were to set up the ratios, you would do 1/4 equals 1/4, which equals square root of 2 over our hypotenuse, which is x. And then you would cross multiply. X times 1 is x. 4 times the square root of 2 is 4 square root of 2. And we get the same thing, okay, as you can see. Now, it's not really necessary to set this up when your leg is just a constant, but you'll see there will be cases where we will want to set it up. So here, we now know the hypotenuse, and we don't know either of the leg lengths, x and x. So 1/x equals 1/x. So again, this is your leg, and this is your hypotenuse. So again, you always just start with 1, 1, and square root of 2. Okay. In the denominator, you put the length of the leg the length of the leg, and the length of the hypotenuse. Now, before I cross multiply, I'm going to simplify. What is the square root of 2 divided by the square root of 2? Anything divided by itself is just 1. So really, I have 1 over x equals 1 over 7. And now we can cross multiply. 7 times 1 is 7. 1 times x is x. So we know that our leg length is 7. Which makes sense because this is a leg, this is a leg, this is a leg, and this is the leg times the square root of 2. So you can see that we knew the leg had to be 7. So now, based on the last example, if this is leg times the square root of 2, then we know that 2 is the leg length. So that's what x equals. Now, if you were unsure, then you could set up the ratios. So you're always going to start with 1, 1, and square root of 2. This is your leg, and your hypotenuse. So my leg lengths are x, and my hypotenuse is 2 square root of 2. So just like the last one, square root of 2 divided by square root of 2 is just 1. So we have 1 over x equals 1 over 2. Cross multiply, and we get 2 equals x, which we identified from the very beginning. So again, you don't have to set this up if you recognize that it's leg times the square root of 2, which means that the leg has to be 2. Now it gets a little harder because our leg length is not a constant. So this is an example where you would want to set up the ratios. So leg, and this is the hypotenuse, which is leg square root of 2. So you could, right, if our leg is square root of 6, you could do square root of 6 times square root of 2, or we can set up our ratios. So you always start with 1, 1 square root of 2, leg, hypotenuse. So my leg lengths are square root of 6, and my hypotenuse is x. So now we can just cross multiply. I'm going to use these two. Remember, these two are always going to be the same, so it doesn't matter which one you use. So cross multiply, x times 1 is x, square root of 2 times square root of 2 times square root of 6. Well, we learned in the last lesson that we can just write these under the same radical, so that gives us the square root of 12. But we know the square root of 12 can be simplified. 4 times 3, 2 times 2. We have a couple that's going to go out to one restaurant, and then we have a single that needs to stay in. So square root of 12 simplifies to 2 square roots of 3. So that's what our hypotenuse is 2 square root of 3. So that one was not as easy to tell without setting up our ratios. Okay. These are you tries, but I'm going to go through them with you. So since both of our legs are just numbers, we know, so leg, and our hypotenuse is leg square root of 2. Well, our leg is 6, which means the hypotenuse has to be 6 square root of 2. So when the leg is a constant, you don't really need to set up the ratios. But if you wanted to, we would have 1 over 6, and square root of 2 over x. And you'd cross multiply, and you get x equals 6 square root of 2. Okay, for B, since our leg is not just a number, it's the square root of 10, it would be beneficial to set up our ratios. So 1, 1, square root of 2. Okay, my legs are both square root of 10. Remember, the legs are always going to be the same. And then my hypotenuse is just x. So I'm going to use these two ratios to cross multiply. X times 1 is x. Square root of 10 times the square root of 2. Well, we learned in section 10.1 that we can multiply those under the same ratio, which gives us the square root of 20. And now we need to simplify that. So 20 can be broken down to 4 times 5. 4 can be broken down to 2 times 2. I'm just going to cross that out because We broke it down further. So now we're going to look for couples. So we do have a couple and they go out to dinner once, or they go out to one restaurant. Okay. And then we have this single here, the 5, and that guy needs to stay on the inside because he's single, so he doesn't go out. Even though none of us are really going out right now. So square root of 20 simplifies to 2 square root of 5. So our hypotenuse is 2 square root of 5. I'm not going to do this one. We're going to skip this example. And that's it for 10.2.